It is the 4th of March 2023. This is an update for the driver on the ESP32 driving a stepper motor. So the stepper motor driver, and I guess I need a pointing device here. I will use this one, I guess. So on my first try, I got this stepper motor connected to this stepper motor driver with the wires in this order, and these wires weren't exactly the same. I jumpered, I guess it would be clock and PDN, which aren't what these pins are called. Basically, I connected two of the inputs together because they were normally tied high. I got the stepper motor turning the correct way. Things were going good, and then this little chip got too hot. I followed the directions for changing the little potentiometer for setting the maximum current, but apparently the voltage either ignored it or I ran it. I had the wires crossed to begin with, so it one direction was actually pushing it this way and the other one was pushing it that way. So one coil was pushing one way and one coil was pushing the other way, and the stepper motor got warm. So anyway, that failed, so I killed this. That is when I ordered this version. So these guys, we'll just get the box out. These are BigTreeTech, and they are part number TMC2209, version 1.2. It came in a set of 4 instead of 1 at a time. They're a little bit more expensive, but they are supposed to be quite a bit quieter for driving the stepper motor, which is something that I would like. And they also have a much higher maximum current. So what I'm doing is I'm feeding 5 volts to the VDD that is coming from the 5 volts on the ESP32. Ground is from the ESP32 as well. That's what the green wire and the red wire are for here. A2, A1, B1, and B2 are the coils on the stepper motor driver, or the step motor. Power for the stepper motor comes plus 12 volts there and 0 volts here. That's coming from this battery over here. Or it's going to come from that battery over there when I connect it up. On this side, we have direction and step, which are connected to pins on the ESP32. The clock, PDN, and PDN are all not used. EN is not connected, and MS1 and MS2 are connected together. So that's the way it's set up, which I believe is in half step. So the stepper motor driver turns at 1/2 the speed that it would normally turn if I had it in full step. At least I believe that's what's going on. When we get to checking out the maximum speed, maybe I'll have to change my opinion. So we're taking the USB from micro USB from the laptop and just plugging it in. Make sure I plug it in right side up. Okay, it's plugged in. I am going to go into my Arduino code. So this is the first time I tried this, was the 25th of January, so I just left the code in here with the 25th of January. So here we have direction is pin 12, step is pin 14. We got 200 steps per revolution. And then we set the pins to output. We set the direction high and say spinning clockwise, and we do that for 200 times. And then we have some delays in between. And then we have a 1 second delay, and then we change the direction and spin counterclockwise for 1 rotation, then we delay for a second. So nice, simple. We're going to download this code. We see here that the compiler is doing its thing. And then when it's ready to go, I am going to press this button and hold it down. And it downloaded the program. We're going to Control-Shift-M. And we should see, okay, let's try it again. Okay. I'm not sure why that didn't work this time. Control-Shift-M. Let's do reboot. There we go. Clockwise, anti-clockwise. Okay. So then I'm going to go into a drawer, get a couple of banana plugs. We're going to connect 0 volts on the battery to green. And we're going to connect 12 volts on the battery to red. And it turns a little bit. Now, that doesn't look nearly like some clockwise, anti-clockwise, clockwise, anti-clockwise. So that is the correct direction, but it is not going very far at all. So we're going to change the code. I would say that's not even a quarter turn. 1/8 of a turn, maybe. So let's say 1600 is a full turn. And send the program down. Well, I didn't have to push the button. Control-Shift-M. And then we'll give it a reboot. Okay, I'm going to say that, well, first of all, it doesn't appear to be. I'm going to say that's not even half a turn. Okay, so let's say 4,000, for example. Let's download it again. Push and hold the button. There we go. Control-Shift-M. Okay. Going much slower backwards. I'd say that's over a turn. Anti-clockwise is much slower than clockwise. Okay, that's very odd. I'm going to take power off. Check this. Check this. Okay, this is getting warm. So the pins are straight through, right? So this A2 goes up the black wire, and it goes to my connector here. So the black wire goes to black. The white wire, which is the next one in line, goes to green. So black and green on here is, so this is black, that's green. And then blue and red, blue and red. So I don't understand exactly why it would be going the wrong direction, or it would be going slower in one direction than the other, but I suspect the coil could be going the wrong way. We'll just try it, and then we'll connect up our positive again. Let's see what happens. So anti-clockwise is slow. Actually, so now clockwise is slow and anti-clockwise is fast. Okay, so that didn't help. One direction is faster than the other. I don't believe that that is how it's supposed to be. I think it should be going the same direction, same speed in both directions. Let's just go take a look at the code, make sure. Okay, so there is, I'm going to say 3,600 maybe steps per revolution. So it is going high 400, low 400. Same thing for high. Oh, it goes slower. 400, low 400. Okay, so there was actually a longer delay, so that makes sense. Well, it went slower one direction, although I don't know why changing one coil would have made that happen, but I'm going to push the button, and then we're going to hook up 12 volts. Okay, that's more than a full turn. So I am going to go back to 3,200 for the turn. Since it's 200 turns per revolution, it's supposed to be 200 turns per revolution, or 200 pulses per revolution. I am going to say that that I've got it in 1/16th step. And that looks, well, doesn't look like it's exactly one turn, but it's pretty close. So instead of 200 pulses per revolution, I've got 3,200 pulses per revolution. That's, yes, we'll then switch to the second example. So I didn't show you checking the signals on each pin, but before I hooked up to 12 volts, I checked all the voltages on each of the pins, whether they're high or low, 5 volts. And when I disconnected this and put the 12 volts on, and then just went through and checked what the voltages were, and it's not 12 volts, at least it's so fast turning on and off the 12 volts that my meter doesn't catch it as 12 volts. It catches us at about 5 volts. So it's a 12 volt power supply, but it's not actually staying on very long. So we're going to go to the second program, which is January 25th B, and it uses same direction and step pins. And then it says set max speed at 1200, acceleration, and then it moves to 3600. So 3,200 is what I think we have for a full revolution. So I'm going to make it go 2 revolutions. I'm going to change it to 7,200. And then what it does is it spins back and forth, right? So we're going to upload that, or we're going to compile it, I guess. And it seems to want me to hit the button this time. Control-Shift-M. Okay, so that is okay, that's 1, 2, 3, 4, 4.5 turns. Okay. I don't understand what that unit is then. Let's see if I can speed this up. Let's try 2,400. Which is twice as fast. One, two, 3, 4.5. 1, 2, 3, 4.5. All right, it's going faster now. Let's double it again, 4,800. And I don't really know about this position. Let's go 10,000. Okay, downloaded. Okay, that's too fast. I'm going to actually turn the power off because I don't want it to overheat and destroy anything. So 2,400 it did, 4,800 it didn't do. Let's try 3,600. And I'm going to change it back to 7,200 because I changed 2 things at once and that's something that I shouldn't do. That does not look good. So that's too fast as well. Let's try 3,000. Okay, that's still acting weird. We're going back to 2400. Make sure that it works as I remember it working. That doesn't look quite right. Not happy. This connector is in, that connector is in. How are we? Okay, we're going to change it. Back to 1200, where I started. I'm going to change it to 10,000 as the position. One, two, three, four, 5, 6. 6 and a little bit. Okay. It's not turning very fast, but it looks like I have it in 1/16th step. So I can probably make it go 16 times as fast. So I will bring up a clock. I bring up a timer. Let's go take a peek at settings. Of course. I'll use my phone. Stay porch. Okay, so 1, 2, 3, 4, 5. 5 in 13 seconds is a little faster than one revolution in 3 seconds. So if we make it 16 times faster, 5 times 16 is 80. So 80 revolutions in 13 seconds is 5 revolutions per second. I need a calculator. So if we go back to a regular calculator, 13 point, all right, 5 divided by 13.33 seconds is 0.375 revolutions per second, and multiply by 60. That's 22.5 revolutions per minute. Okay, if we multiply multiply that by 16, if we get it into single step, that's 360 revolutions per minute, which is quite substantially more than I need. So I shouldn't have to worry about the maximum speed, although it would be nice to change MS1 and MS2 to whatever I need to get single step. Guess that would have been inside the box, wouldn't it? Well, first of all, I shouldn't have dumped that out, because now I have to find this last little guy. And I have, yes, I'll have to open up and, oh, I'm still recording. These files are going to be big. Okay, 30 minutes, and we'll shut her off. And then we will go over here. Minimize. Yeah, 27 minutes.